Hi, welcome. In this tutorial, we will create a logger. It's about time. And then we will create some Vulkan helper functions for stuff that we will be creating more often in the future, so that we get our program organized a bit with stuff that we will be reusing. Remember to be in the correct branch. All 5 Vulkan renderer cleanup. The first thing that I want to create is a logger. And the reason why is because I have these to-dos in here and I want to get rid of them. I want to get rid of the standard library. I want to show you why. If I were to define static as internal and compile the program, currently it complains about some weird stuff. More than one storage class specified. The reason is because the standard library IO stream defines internal, and so if you want to use the internal keyword as I am, or if we want to use that, we cannot use IO stream at all. So we have to implement our own logging function. If you like what I do, consider tuning into my Twitch. I stream at 10 a.m. Central Eastern Time, which is 1 a.m. Pacific Daytime. You can also support me on Patreon. I've set up a new page. Supporting means getting access to the game code that I'm currently working on, which is Cake's Tower Defense. And I want to do that. So let's open platform.h. In order to start our logger, we need to first create a function void platform log, takes in a char pointer, I guess a const char pointer, to a message and some other stuff like a text color, which will be an enum that we'll define here as well. Enum text color. That makes it so that when we output to a console, we can define different colors to express our intention. An error will be red and a fatal error will be light red. Something that's just tracing will be green. You'll see what I mean. So we type in text underscore color and we will have red, and let me copy those a couple of times. We will have green. I guess we'll also have white, yellow, red, and I call this red intense or light red. Could also be light red, right? Let's call this light red, like so. The comma doesn't do anything here. It's fine. Let's just implement this function here real quick. Platform log, yoink that, paste it in here. Boom. Well, what do we need? First, we need to get the standard IO handle. And in Windows, we have to call a function called get std handle. And it's called std underscore output handle that we have to get. That's a define. You can look at this. It's a D word -11 if you care what that is. Returns a handle, and I call this console handle. We have the console handle, and then we can set what is called console attributes. And these console attributes are just bits, very easy to read once you know what they mean. For example, we define a UN32T here, call these color bits, define that as 0, 0, and then switch on the color, like so, switch on the color and remove that. Then we do case. What do we have? Text underscore color. And the reason why I use text underscore color is so like this. I can, most of the time, you will not have anything in your program that is text underscore color, and therefore you have IntelliSense working with you, helping you out here a lot. So we have green, and then we do break, and you could just copy this a bunch of times and paste that in here. I think we have 5, so we have green. I guess we have white first. White, whoops, green, didn't need to delete that. Yellow, then we have red, and I think it was light red. Light red, there we go. Okay, I like to put a break between those. You can do whatever you want. And what do we want? Well, we want to set the color bits to some bits, right? And if I remember correctly, that is called foreground. There we go. Foreground blue, green, intensity, and red. So what do we want? We want white. And I don't know if we have to specify all of them to get right. I tried with all of them, or if we can just specify nothing. But I'll specify all of them because all of them together are combined to white. And then we can just paste a couple of times here. Boom. What do we need for red? We just need the red part. For yellow, we need green and red. For green, we just need green. We're not using blue. If you want to use blue, then use whatever you want. And for light red, we take red and that with foreground intensity, which intensifies the color. Boom. Now we have the text color bits, and then we can do what is called set console text attribute. Takes in the console handle, which is the console handle, and the attributes, which are just the color bits. And if you want, you can play around with these values. These are just, if you look at them, defines to be some bits. There's a lot more stuff that you can define, like the background and foreground. You can create some interesting stuff here. You can also look this up on docs.microsoft.com. I will put a link into the description to this, but it basically shows you what I already showed you. Once we have set the console attribute, we can then do write console A. And remember, the A means ANSI. Takes in the console handle, the message, the number of characters to write, which I would just specify as a string length of the message. Now this assumes that the message is now terminated, and reserved, we don't care about that. There's also one more thing that we can do, which I find very cool, which is if dev debug, and I'll put this into a debug thing, and that is called output debug string A. Again, A for ANSI. And the only thing we need to specify here is the message. Whoops, like so. And I guess I forgot number of chars written is not important. And the flags, yeah. We don't need to save the number of characters written. And now we create a new file, and we'll just put this in source, logger.h. Boom. Since this is a .h file, we do a pragma once. There's one thing that we need from the standard library. First of all, well, we'll need the, of course, we need the platform.h. If I can type platform.h. Thank you. Let's do a comment here. Standard library. I'm putting this comment here because for me, it was not really obvious when I started learning C++ what the standard library actually is. For example, the stdio.h is standard library. You could probably discover that from the name. I hate when I forget words, man, because it has a std. Anyways, to me it wasn't obvious, okay? So what do we need? We create a void underscore log function. And this log function is not meant to be used. That's why I put an underscore there. Oftentimes in programming languages, the underscore in front of a function means please don't use this. You can still use the function if you want to, because we have no way of limiting the access. We need the access here because we will define macros. You'll see why in a second. So what do we first need? I like to make this as simple as possible. So I define a char pointer to a prefix that will be in front of every message, like trace, error, morning. You'll see why. Then obviously we need the text color for the text. Then a const char pointer to a message, and this is going to be the only template that we will be using, args. We need variadic arguments, meaning a variable amount of arguments, and so we need to specify a template here. I tried various other things, but this one is the easiest one to use, even though it's like introducing a template which might not be as comfortable for everyone. So what we type in here, template, and then type name ... args. I guess it's called args, like this. So these are just the variadic arguments that we will be using in this function. And inside the function, all we specify is a char buffer, which I call fmt buffer, on the stack, because I don't want to do any dynamic allocations during runtime. So we'll allocate two buffers. We need a format buffer and a message buffer. And I know technically this can overflow, meaning that the message can be longer than 32 bytes, but I have not had that happen to me while programming on my engine, and I've been programming in this for over a year now. So maybe you can make it so that these overflow, maybe not. If you make the message too long, you can break anything. Anyways, so yeah, we'll be stack allocating those two, and then we'll call sprint f 2 times. First, we take in the format buffer, fmt buffer, and we type in a format string, which is basically a %s for the prefix, colon, a %s for the message, %s in small please, and a \n in the end. It takes in the prefix and the message. Then we copy that. Again, we type in the message buffer, and then we sprint f into we use the format string is then the format buffer, fmt buffer. And the only thing that we supply here are the arguments. And I'm supplying the template here because for using the template, I can just supply the args like this. You cannot do the following. This doesn't work. And I'm rather new to this type of stuff. So that works for me. I know that there is also a VA underscore start, this one, but I don't know enough about compilers and whether this is compiler specific or not, and therefore I'm not trying to use it. If anyone knows more about this, feel free to correct me in the comments or point me to a better way. And that's just how we are doing it right now, and I'm always happy to correct myself. So yeah, let's continue. We have the sprint fs, we have the message that we want, and then we call platform, not read file, platform log please. There we go. We log the message buffer in the color. And I forgot something. In C++, you can initialize buffers to 0 by typing equal and open close braces. And we'll initialize those two buffers to 0. So to make sure that they are 0 initialized. In debug builds, this won't be a problem, but it could become a problem if we try to run in an optimized build or create an optimized build. These might not be initialized to 0 to be faster. So we have to explicitly do this here. Okay, so this is the private log function that we will not be using. Now we define a bunch of functions. Trace, let me quickly do this 4 times. What do we need to do? Trace takes in a message and variadic arguments called log, and then as the prefix called trace, the color text underscore color underscore, and I suppose this is not helping me out here, so text underscore color underscore green for trace. The message would be the message that we want, and the arguments would be underscore underscore va underscore args underscore underscore. And you bet that we will not only be using trace but error and warn, and I call fatal. There could be more, but those 4 should be fine. Error, warn, fatal. Quickly noticed it's supposed to be green, not green. So yeah, we use text underscore color underscore. For error we use, and I just noticed error is out of place, we use red. Put this one down right in front of fatal. And for warnings we use yellow, and you bet for fatal we use light underscore red. And this is the point where we have to be careful, because error can be defined. I will not be using trace, warn, and error by themselves. I will prefix those with cakes. You can prefix those with whatever you want. Just wanted to tell you that since we are not using, you could also be using in the entire engine, you could also be using a namespace, cakes or something, which I use in my other engine. I just try to keep it as simple as possible, and therefore it's not really needed because we are not using any libraries. But if you were to use libraries, you would introduce some sort of namespace, or you would make sure that your functions are definitely prefixed with something so that you don't have any trouble with libraries. Okay, so but that is not everything that we will define. We will define another thing, and that is cakes assert. Takes in an X, which would be an expression, a message, and of course variadic arguments. And we have to specify the backslash here to signal that we will be line breaking in order to make it easier for us to type. And the first thing, let me put one here as well. The first thing we type is, if brace brace, the expression is not true, put an exclamation mark here, then we do something. And I like to do a cakes error with the message and the underscore underscore va underscore args underscore underscore. Put a semicolon here, backslash here again, put another backslash after the semicolon, and use the auto formatter if you know how to use them. For me it is Shift Alt F to auto format, and we put in another thing which is underscore underscore debug break, and don't forget the backslash to signal line breaks. What this will do is whenever an assertion is hit, it'll halt the program at this position if the assertion is not met. If we don't want the user to have this in a release build, we have to if guard this to if def debug and elif and if like so. And what we do in the case when we don't have a debug build, we just define it to nothing. Okay, that's a simple logger. Quickly compile and see if it still works. It probably doesn't there because I forgot to remove stdio. So let's try to remove every occurrence of IO stream, Oh yeah, there we go, IO stream. Have to remove that, and then we have to replace all of these std outs. I will call a cakes error here. Oh, I forgot to, we have to include the logger. A, B, C, D, F, G, H, I, J, K, L. So include logger.h, like so. And then we can do a cakes error here with the message Vulkan error. And the cool thing is that we can just do a %d here for the result, because that is a number, and then use the result in here, and we are done. Don't forget the semicolon here, and then it should work fine. Over here we will be using also a cakes. You could also be using a cakes assert here, or an assertion. I like to call cakes error. I have been using cakes assert in the past. Cakes assert would just be cakes, instead of cakes error, you would do assert and then put a 0 here for nothing, and then the message with no arguments. Could also be doing that, right? I guess we'll do that. Okay, what else do we have? We have all of these stdc outs here. Assert and error checking. What we can do here is cakes assert 0, then failed to read file. Put this in here. And I guess I failed wrong. Failed like this. Failed to get file size like this. Boom. And failed to open file. And I like to add in a cakes error here, just for later, in case we did not take care of every problem during the development and we ship the game, let's say, so that the error will still track the problem for us in a log file or something. And so when we see a log from a different user, we know, oh, I couldn't open this file interesting. And we can do some more stuff. For example, fail to get size or file %s, and then we use the file. I think it's the file name. Oh, it's the path. Okay, so we take the path here. We put the path in here. Right, we can add that. Fail to open file %s path. Let me quickly put this in here %s. So these to-dos go away. More or less, we could do way more than just this. But that should be enough in the beginning for sure. Keep us safe. I know oftentimes I'm kind of over preparing, but it's good to think about this. And oftentimes I feel like these assertions and error handling in general is kind of overlooked, which is something you definitely have to think about. You don't want to crash on your user. I feel like crashing is the most stupid thing that you can do, and losing progress or anything, right? Losing what you have played and having to start a program again that might take like 10 days to start. I hated that always, and it made me stop play some games because they weren't handling these kinds of things properly. Okay, let me quickly fail to read file, change these failed to get size or file, failed to open file. Okay, there we go. And I guess failed is spelled wrong here as well. Wait, those. Why can I not type failed, man? There we go. Okay, so don't do these spelling mistakes like I do. I think that's enough already. Let's see. Can we compile? Args parameter pack must be expanded. Oh, I think I forgot to... Oh yeah, we can't use just args. We have to do args ... templates, ladies and gentlemen, templates. I don't know. Okay, don't forget the 3 dots here. Compile again. Should work. And I think everything should work fine. Okay, it still works fine. Good. Close the program. And I will be removing this VK check here. It's triggering me because it always stops me from closing my program. And the only thing that is complaining currently is that we resize the window and therefore destroy the context. Right? So that should fix this annoying problem. I wanted to do this in the longest time, man. We have a logger now. We can log some information and we can try logging something as a test. And let's say if VK context instance, if we don't have an instance, right? We wanted to throw an error or something. I just wanted to demonstrate the different logging that we can do. Let's say error. This is a logging message. Paste those and start with trace, then warning, error, and fatal. So we have those. We run the program and look down here. This is a logging message. This is a logging message. What we see here is not the actual console, but the debug string A that we do, because this is some sort of different console. Don't ask me exactly what that is, okay? Please. It's basically a different output path that we can use. In case we open a console, which we can do in VS Code, but also when just starting our program. Let's say we are in the folder of our program like here. We can start the main exe, and down here in the console that started, we see the different messages pop up in different colors. So this is like a quick check if it actually works, and it does seem to work very nicely. And in the future, what we can do is change these VK checks and check if the instance was actually created, and then return a proper error to the user by logging the proper error or using a message box. So basically what we can do in here, in case we fail, what we could do is cakes failed to initialize Vulkan. And we put another fatal error here and say failed to open a window. And I suppose we can put another one here. Failed to render. This will probably not fail most of the time, so putting it there anyways. Okay, so in the renderer, I just want to clean up a couple of things. We have already done a lot of stuff, but I want to set ourselves up for the next time where we will add a game layer in which we can then create entities to create duplicate quads on screen so that they can move around. So yeah, stay tuned for that. The next episode will be a game layer and entity creation, which is very exciting. This will be the first step on creating an actual engine, in my opinion. But before that, I want to extract 2 functions that we'll need later. And for that, I create a new file called vk_util.cpp. And the first function we'll implement is called vk_allocate image. We don't know what we'll take in yet, but we know what we will return, which is an image, the one that we created the last time. We need to get the proper include here, which would be vk_types. So we know about this. And then we go back into the vk renderer down to create image and copy everything that has to do with the allocation of the image up until bind image memory and paste it in here. And so what do we need in order to allocate an image? We need a UN32 width, a UN32T height. Quickly put this in here with height. We need a format, which is a VK format. The image usage we won't touch, so I will not create a parameter for those to change them. In case we need to change them, and we'll probably need to in the future, then I'll add a parameter for this. But for now, we don't. We need the device. So VK device here, device, like so, remove the device. And so now it's asking for the image of the VK context. We will not be supplying the context, but instead we create an image on the stack here, image, and initialize that to 0, and then pass in image.image over here, like so. That takes care of this. No VK context device. We pass in image.image. We get the memory requirements. I see we need the GPU. So up here, VK physical device, GPU. Boom. We have that. Oh, VK check is undefined. I see. Interesting. So we can't access VK check in that. So we will extract this out of the VK renderer. And also the array size in the VK renderer. Please put that in the defines range. The VK check should be in VK types, because VK types is something that every single Vulkan file will include. And I guess since now we do a cakes error here, we don't have the logger, we also need to include the logger. And the way I'll do this is I'll put the logger, the include of the logger above the Vulkan include, because I like to use the library includes at the very bottom. And while we're at it, we will not be using the return false anymore in the VK check, because otherwise this will try to return false, which is not an image, and therefore it'll complain, meaning that we have to change our init function, the VK init function, at a later stage, because now it no longer returns false when, let's say, the instance could not be created. In debug mode, it would tell us, but if we were to compile in release mode, this would do nothing for us. It would just print out an error and continue, which is not something we want. We'll take care of this later though. For now, all we need to do is have these VK checks in here, so they tell us if something could be created or not, which is very important to us when debugging our program. Okay, next thing, the texture size is actually something that we don't have to supply to this function when we allocate texture, because in the memory requirements, we have a size field and can use this. Replace every VK context device with device, and every VK context image.memory with image.memory, and VK context image.image with image, and image VK context memory image.memory with image memory. In the end, we return the image, and that should be it. Quickly check if I forgot something, make the parameters have proper format, and then it looks good. Okay, so instead of all of this, bind image memory, what we do is VK context image is VK underscore allocate image. And I guess we don't have VK util in here. Okay, we need to include that real quick. VK underscore util.cpp. Go back down here. What do we need? VK context device, VK context GPU, and let's not call this data anymore, but file. I feel like data is a bit misleading. There we go. So what do we need? Well, the file header.width, the file header.height, and the format of the texture. Let's break this up here real quick though. So, and call this VK format. And the same thing we had R8, G8, B8, A8, unorm. We allocate this type of image. Quickly check if that actually works. Data undeclared identifier. Luckily we get an error. Data, we no longer have data, but file and file over here. Change those two. Check if everything still works. Looks good. Nice. Okay, do we have any errors? We don't, which is great. Okay, that's the first thing. We want to allocate an image. That removes some of the code over here. The next thing that I want to extract is the creation of the staging buffer. And by the creation, I mean the allocation. So yoink that, go into VK util and create a function called buffer, VK underscore allocate buffer. We don't know the parameters yet. Paste in everything, but I'm pretty sure we need a VK device. Then we need a VK physical device, GPU, and some other stuff. Probably a uint 32T size. So first of all, the size here that we want to allocate. We need the buffer usage, which I thought, yes, we would need. So VK buffer usage flags. Not flag bits, but flags. Flag bits is like the enum. Flags is the type def for the uint32t. So let me show you what that means. Basically, VK buffer usage flags is a type def for VK flags, and VK flags is just a type def of uint32t. So we need a uint32t here, basically, is what they're saying. A mask. Let's call this buffer usage, and then supply that over here. Buffer usage. Quickly replace the device here, and do the same thing that we did with the image. Create a buffer, initialize that to 0, and supply that to those functions. And then we'll return the buffer later, once we are done allocating. I just noticed I can't spell device. There we go. Okay, that looks good. Quickly, I want to change the buffer in VK types. I also want to store the uint32t size of the buffer. I find that very interesting and usable, so whenever I create in a buffer, I store the size in it, so that later, when I try to copy to a buffer, which will be another helper function down the road, I can check well, do I actually have enough size in the buffer to copy? And therefore I can terminate the copy operation before I get a problem. So yeah, let's quickly replace all of those functions here. Buffer.buffer. We get the memory properties from the GPU. This should be fine. Then we allocate on the device, we map on the device, we bind buffer memory on the device, and here we use buffer.buffer, and here we use buffer.memory over here as well, and buffer.data, and again buffer.memory. Looks like I have a problem. Let me see. No, I don't. Okay. Now there's more to it than just what we did. We want to also specify the memory properties of the buffer. We want to specify the VK memory property flags as a parameter and pass them here as well. So VK memory property flags, memory props, or let's call them mem props, and we want to supply them. Whoops, mem props, like so. Very important later. So we'll be using this. I guess I can't spell mem props here. That should be fine. Looks like I had one too many braces here. Be careful with this, but we will be extracting this in a second anyways. I just wanted to check if this works. Compile this real quick because it looks like everything's fine. VK allocate buffer must return a value. Of course, we don't return the buffer here. Return buffer, but we are not done yet with this function. Okay, that looks good. I'll quickly check if that actually works. So instead of doing all of this stuff, we call VK context staging buffer is VK underscore create buffer. No, not VK underscore allocate buffer. We need the VK context device, VK context GPU, 1 megabyte of size, and then VK underscore buffer usage. And we can see this down here. It is transfer source bit. The next is the memory properties. We want host coherent and host visible. VK underscore memory property host coherent bit and VK underscore memory underscore property host visible bit. And I think that's it. And let's try if that actually works. Remove the entire buffer creation. Let me clean this up a bit. It's kinda messy. Break this up a bit. Okay, build, let the program run. Seems to work, very nice. But there's one more thing that we have to check in allocate buffer, which is very important. We call map memory here, but we can't map memory that is device local only. So we can only do this if the mem props and VK underscore memory property host visible bit is set. If we have that, then we can map the memory. And I'll leave a comment here that describes it's only map memory we can actually write to from the CPU. Another thing that I wanted to do is extract this stuff into its own function, into its own helper function, which I call uint32t vk get memory type index. Don't know the parameters yet, but one sticks out immediately is the vk physical device, CPU. Then we need memory requirements. So VK memory requirements, not 2, but 1. Mem requirements, like so. And the properties, memory properties, VK memory property flags. And let's call them mem props. That looks good already. We need a return type, uint32t. Type index is uint32 max. And the reason why I define this as max is if we don't find the proper memory type index over here, type index is I, and then we break. If we find the proper, I guess I have to type properly. So if we find a proper index, everything is fine. But if we don't, we want to know about it. And therefore we put a cakes assert here that the type index is unequal to uint32 max. We could also define an invalid index to be uint32 max, which I'll probably, let's do this now. Let's define invalid index to be uint32 underscore max. And I guess I have to do uint32 max like this. So let's use invalid index here. Invalid index like so. And invalid index. I failed to find proper type index for memory properties, and then we supply the memory properties that we tried to get but didn't get, which is mem props, like so. This will at least during debug mode show you if you have the correct memory properties available to you. And if anyone has trouble with those, they should see this assert fire. Then return the type index, like so. Because now we can actually do the following. So instead of all of this, the only thing that we need to do is alloc info, do those two things, and then the alloc info.memory type index is vk get memory type index, pass in the GPU, the mem requirements, and the mem properties, which is vk memory property device local bit, like so, and delete all of this stuff. I think that one too. We just need to get the memory properties, requirements, excuse me. Test that real quick if that works for the image. If that works for the image, we do the same thing for the buffer. Seems to work, of course. Why shouldn't it? Right. And then we do the same thing for the buffer. Allocate info. We have the size, which is not 1 megabyte. Also had an error in here, which would be the buffer.size. Delete all of that, all of this, and that would be vk underscore get memory type index, GPU, mem requirements. Please don't break on me. Thank you, IntelliSense. And the memory properties would be the mem props that we supplied via the function. And we can delete this. We just need the memory requirements for the buffer. And I feel like, do I have a problem or is this just IntelliSense being slow? Okay, it's IntelliSense being slow. Run this, and I think I have an assertion. Structure type memory allocate. Oh, I guess I accidentally deleted the, okay, allocate info dot. And that's very nice. Have you seen that? It stopped on the assertion here. We had an assertion and it stopped on the first assertion. Yeah, because we put cakes assert here. But that's very helpful when debugging your application. Allocate info dot s type. Oh no, I don't want to type this. I'm going to yoink this real quick. Yoink, paste. Okay, let me see here. Boom. Okay, IntelliSense is being slow, but the program is running. I just noticed a problem. The allocation size of get memory type index cannot be 1 megabyte. It has to be mem requirements.size. Cool. So that is more or less what I wanted to show you today. It's not that much actually, but I feel like a shorter video from time to time is also very good. We created a logger. We added some simple interface functions to allocate buffers and images. We will add more later. For example, what we will do is a void vk underscore copy underscore to underscore buffer. I guess we can do this now real quick. It's like the last step that I wanted to do. It's like the mem copy over here. Basically what I wanted to call here is vk underscore copy to buffer, and then implement that, calling the mem copy. And what do we want? Well, we need a buffer pointer buffer that we want to copy to, a void pointer data, and a uint32t size. First of all, if we can do an assert here for the time being, cakes assert is that the buffer size is greater or equal to the size. That is an assertion. Otherwise, we can't copy to this buffer. Buffer to small for data, and let's do some percentage d's here for data, percentage d, and then we do buffer size and size in the assertion. Quickly remove this because this is destroying IntelliSense. And then the mem copy, all we do is buffer data, we copy to buffer the data and the size. But we only do that if buffer data, if we actually map data, meaning why is this actually complaining? It's only complaining about memcopy not being able to find memcopy, but that's not true because memcopy is actually defined. We might have to include some header here, but in Windows.h actually it is defined. When you include Windows.h, it is actually defined. So IntelliSense, guys, don't get fooled. File data begin. We call the vk copy to buffer here, and the size would be the texture size we want to copy. And let me quickly check here. We only do that if we have map data. If we have mapped data. Otherwise, we need to do implement copy data using command buffer. Just like with the image. Quickly compile that and try to run. Still seems to work, so everything's fine. And for this, we might have to include some stupid SCD stuff because it is actually defined in Windows.h, but the Visual Studio Code can't find it. I guess what we can do here is include string.h, just so VS Code does not complain about memcopy. I guess I'll put it to do in here. If we get to it, we can do a platform mem copy, which would get rid of this stupid include, but I'll leave it in here for now. It's fine. Okay, guys, that's it for the tutorial. The next time we create a game layer and make entities move around. What I'll do now is the git stuff. So basically all I do is git checkout -b, and let's call this alpha 06 Vulkan underscore, let's call this game underscore layer, and then we do git add. Boom, git commit -m. And I noticed, wait, before we do anything, I need to add in a file .gitignore because for some reason it was lost. The only thing that I need is main.star and win32 underscore platform.star. That's the only thing that I need, basically those files here. And in order to get rid of them, we have to git rm, and then we do dash dash cache, and we want the main exe, we want the main ilk, we want the main pdb, and we want the win32 platform obj. Git commit -m, call this edit logger, and vk utility functions to create images / buffers, and git push. Do I want to push this branch remotely? And then git push -u origin 06 _game_layer. That's it, and I'll see you next time where we create a game layer.